So yesterday we took a look at the distributive property. That is, we expanded brackets and tried to get rid of them by multiplying all the terms in front. And that was fantastic for what we wanted to do yesterday. We wanted to see our degree. We wanted to see our leading coefficient. We got okay at getting rid of those brackets. However, if we want to graph a polynomial, we know this form, which we call factored form, right here, is better for us, right? Because we can see our zeros, we can see what kind of zeros we have, we can see our leading coefficient, all that good stuff. Unfortunately, as we know from yesterday, there's different forms you can get an equation in. So yesterday we wanted to get rid of the brackets, today we want to put them back in. Okay, so we're going to be factoring today. That is, we're going to be breaking our equation, our polynomial, into its different parts, which we call factors. Now, there's a bunch of different types of factoring. You guys have done factoring before, grade 10, grade 11. This is sort of reminders of some of those things. The easiest place to start, the most common place to start, is to look for a common factor. Okay, take something complicated looking and make it simpler looking by dividing out something they all have in common. We call that the greatest common factor, the GCF. Okay, when we do that, we'll end up with an expression which has two parts to it. The greatest common factor out front, and what happens after you divide inside the bracket. So it's the exact opposite of yesterday. Yesterday we were doing the idea of, let's take this and expand it and get 2x plus 4. Well, today I want to take the 2x plus 4 and go backwards and say, hey, they both have a 2 in common. If I divide that out, I end up with an x plus 2 left over. Okay. Remember, a greatest common factor doesn't have to be a number. It could be a number, a letter with some exponents on it, or a combination of those things. We'll take a look at some examples to remind you of how this works. Right, negative 12x and positive 4, what do they both have in common? Well, I look at those and I say I can divide them both by 4. Okay, they don't have any letters in common. X is different than y, obviously. But they do have something, sorry, they both are divisible by 4. So my objective here now is take my original equation and divide this by 4. I'll end up with negative 3x. And then I have a plus sign. And then divide this by 4. And I'll end up with 1y. And I can check this by doing what we did yesterday, distributing. If I multiply that together, it comes with negative 12x. If I multiply this together, it comes out to 4y. Okay, let's try the next one. What does 15 and 10 have in common? They're both divisible by 5. I also notice that both terms have an x in them, and both terms have a y in them. Now, the second expression, this one over here, the 10xy squared, has two y's. Y to the power 2, two y's. But because the 15xy doesn't, I can't say y squared is common. They only have one y in that first part. Okay, our idea here is I can't take up more than it has. Okay, this one has one y, this one's got 2. The most I can take out is 1. Okay, so I'm going to divide. 15 divided by 5 makes 3. I had one x, I took an x out, so there's no x's left. And there was a y, but I took a y out, so there's no y's left. Minus. 10 divided by 5 makes 2. There was an x, but I took it out, so no x's. There were two y's, I took out one of them, so I'm left with one of them. And there's my common factored expression. Try the third one. 28a squared minus 4ab. They're both divisible by 4, and they both have the letter a in them. 28 divided by 4 is 7. There was two a's, but I took one out, so I have one left. Minus 4 divided by 4 is 1. There was an a, but I took it out, so all I'm left with is the b. There's our expression. Okay, hopefully we're getting the hang of this a little bit. Try the next one. 45, 15, and 60. Now, yes, they're all divisible by 5, that's for sure. But I want to look for the greatest common factor. My greatest common factor is they're all divisible by 15. Okay, I scan all three of them, and I see they all have the letter A. I got two A's or 1A or 1A, though the most I can take out is 1. The trick here is the smallest exponent. That's all you can really take out. I notice they all have a B in them too. And again, the smallest exponent on a B is a 1. So that's the most I can take out. Let's divide. 45 divided by 15 is 3. There's two A's, but I took one out. There's a B, I took it out. Minus 15 divided by 15 is 1. I took out the A, I'm left with a B. Oops, not a bracket yet. I've got one more term here. And the last part, 60 divided by 15 is 4. There's an A, but I took it out, and there's a B, but I took it out, so I'm done. When you're done, make sure you have the same number of terms as you had in the question. So 3 terms in the bracket, 3 terms in the question. You know you're on the right track. Okay, last one of these ones. 64 and 32 obviously does by 2, by 4, by 8, by 16. It also does by 32. One of the things you should always check is see if they're divisible by the smallest number. In this case, the smallest number is 32, and of course they are divisible by that. I see x's. I have 6 x's or 4 x's. The smallest exponent is a 4, so I'm going to take that out. 2 y's or 4 y's, I can take out 2. 1 z or 4 z's, I'm going to take out 1 z. What am I left with? 64 divided by 32 is 2. 6 x's, but we took out 4. 2 y's came out, 1 z came out. That's all I've got for that first part. Minus 32 by 32 is 1. We took out 4 x's. We took out 2 y's, so I'm left with 2. We took out 1 z, so I'm left with 3. And there's some common factoring. Now, some other things we can do with common factoring. Take a look at the next page here. When we common factor, it doesn't have to be just a letter or a number or an exponent. It could be a expression. When I take a look at letter F here, I notice that the first half, and by half I mean we've got this dividing line down the middle here. The first half has x minus 2 and x minus 2 in it. That whole expression is common to both halves. I'm going to factor out that whole expression. The way it's going to look is I'm going to write down, okay, my expression x minus 2. And if I take that out, let's pretend it's gone for a second here. I'd be left with a 3x on the first part and a minus 2 on the second part. And that's how we can factor something that has more than one part to it. And if you try the next one there, and what do they have in common? Hey, they both have the expression 2x minus 5y in common. So we'd be left with 2x minus 3y factored. Now, if they don't look like that, we could make that happen by combining the two ideas, factoring single pieces and also factoring expressions. For example, in letter H here, they don't have anything common. There's nothing in common to the entire thing. However, if I were to split this in half and look at the first half only, I notice they both have an x in common. So if I took that out, I'd be having 2a minus 3b. If I look at the second half, I notice they both have a y in common. Now, if I take a y out, I'll be left with negative 2a plus 3b, which kind of sounds like the first part, but the signs are backwards. So if I were to take out a minus y, as in if I were to take out that sign, whatever sign is right there, I'd be left with a 2a, and a positive 3b divided by a negative y would be minus 3b, right? And now what do I notice about my brackets? Well, hey, those are the same brackets. I can write down the common part and the leftover part. Okay, by splitting that thing in half and factoring each half. If we give that a try on the last one here, what do I notice? On the first half, they both have an x in common. The second half, they don't have anything in common, but the signs are backwards to what I have. So if I take this sign and put it down here, like think of a negative 1, if you will, I'd be left with a positive x now and a negative y. Hey, that's handy because that's the same thing I already had. X minus y is my common part, and x minus 1 is my other part. And that's about all we can really do with common factoring, okay? So we have single terms, expressions, or splitting in half. And now, unfortunately, that's only one type of factoring. There's a whole bunch of types of factoring. That's a good starting point, common factoring, but it's not our end point. Most of the time when we expanded brackets yesterday, a pair of brackets, for example, x plus 2 and x plus 3, we ended up with an expression. If we do this one, I'm going to skip the step in the middle, but it looks like that. And we call that a trinomial because it's made up of 3 separate terms. 1, 2, 3. Okay. These are called simple trinomials because there is no value in front of the x squared. The value there is a 1. And when we have a simple trinomial, we can work backwards. We can factor by recognizing a couple patterns. Okay, pattern number 1 is, if you recall from last year, the 6 is made up of 3 times 2. In other words, two numbers that multiply and make 6. And the 5 is made up of 3 plus 2. Two numbers that add to make 5. So when I come across a simple trinomial, I need to look for two numbers that add to the middle and multiply to the end. And I have to add to the 5 and multiply to 6. It has to be the same numbers, right? I can't say, oh, I'm going to use 6 and 1 here, then 2 and 3 there. It has to be the exact same numbers. And so we take a look at some of these things here. Okay. Obviously, this is a trinomial. This is a simple trinomial because there's nothing in front of the x squared. So I need to look for numbers that add to 7 and multiply to 12. So I need to think of my factors. 1 and 12, 2 and 6, 3 and 4. I'm writing down all the things that multiply to make 12. I want to find the combination of those that also adds to make 7. And the only one that works would be these two, right? So in my brackets, I have an x and an x to make x squared at the front. I have a plus 3 and a plus 4 because I have to add to positive 7 and multiply to positive 12. And again, I could check this by foiling, right? Expanding again. Let's try the next one. I need to add to 10 and multiply to 9. So what multiplies to 9? 3 and 3, 9 and 1. Oh, 9 and 1 adds to 10. So I can write down plus 9 and plus 1. The order does not matter. If you put the plus 1 first and the plus 9 second, that is totally fine. Okay, let's try a couple more. I need to add to negative 2 and multiply to negative 24. So things that multiply by 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. I want to find the right combination that's going to add to 2. Well, 1 and 24 would make, if I add them, 25. If I subtract them, 23. And that doesn't work. 2 and 12. Add them, I get 14. Subtract them, I get 10. That doesn't work. 3 and 8. Add them, I get 11. Subtract them, I get 5. That doesn't work. Down to the 4 and 6. If I add them, I get 10. If I subtract them, I get 2. Hey, I wanted 2. I want a negative 2. So the order matters of my signs. To get negative 2, it has to be a negative 6 and a positive 4. And it's the only combination that multiplies to 24, or negative 24, and adds to negative 2. Let's try the next one. I need to add and multiply. Now this one's got some extra letters in here, but don't let the letters confuse you. To get an x squared at the beginning, I need an x and an x. To get a y squared at the end, I would need a y and a y. And what adds to 8 and multiplies to 15? Only numbers that do that are 3 and 5. Now some of you are saying, well, where did the xy come from? Well, if I were to FOIL this, x times x is x squared. X times 5y would be 5xy. 3y times x is 3xy. Hey, there's your xy parts, right? And 15y squared. So the letters in the middle will take care of themselves as long as you take care of the first one and the last one. Okay, here's another example, taking care of the first one and the last one. How would I get an x squared, y squared at the beginning? Two things that multiply by each other have to produce that. Well, normally, x and x makes x squared, right? So xy and xy would make x squared, y squared. What adds to negative 7? Multiplies to negative 18. We're getting a minus 9 and a plus 2. The letters in the middle will take care of themselves. Okay, take a look at f. F is different. It looks complicated because I can't think of anything that adds to 4 and multiplies to 16. But there's a nice little trick with f. F can be common factored. So we go back to what we did first today. I noticed that, hey, these are all divisible by 2. We want to take that out. If I take that out, I'm left with an expression that's a simple trinomial. Add and multiply. Hey, I can't lose the 2. The 2 is part of my question, my leading coefficient, right? But I don't need it in the factoring part in the middle. What adds to negative 2 multiplies to negative 8? Negative 4 and plus 2.